All right, thank you so much for joining me today. My name is Brian Egan, and I'm going to be discussing Flutter architecture, or what I call keep it simple state. Hopefully that'll live up to its name. Before I begin, I'll just introduce myself. I'm formerly a senior software engineer at SoundCloud, and before that at Zappos. And so I was working on large-scale consumer-facing applications for Android and web. And so I kind of found Flutter about a year and a half ago and just started throwing as much spaghetti at the wall as I could. So I've kind of developed the redux package with John. I've also been helping to contribute to the RxDart package. And then I started applying all of these things to Flutter and to see what really worked for Flutter. And so I kind of wanted to talk about my journey with that and introduce you to a couple of concepts that I found really helpful. So I think two concepts that are really fundamental is that, number one, your architecture for your applications will change over time, right? Your requirements are going to change. What you use for an MVP or a prototype won't quite be the same thing that you use for your app with like 400 to 600,000 lines of code with like a team of 20 people. Those things are just naturally going to be different from one another. And so when you find yourself sort of progressing maybe from a prototype or an idea stage into more of a team phase or a maintenance phase, I really recommend the technique of layering your architectures. I think this is a fundamental concept we heard a bit about yesterday, and I kind of want to dive a bit more into that as well. So let's look at just sort of some basics, right? We've got a Flutter app. We want to start updating the state of the app, and then of course when that happens, we want to rebuild our widget tree, so we're actually showing the changes. Then, of course, as we start to progress, we're going to need to start to share some data between different widgets, between different screens in our app. And then that's pretty cool, but then we'll actually need to start talking to web services and databases, of course, right? You don't want this like closed off little app that's just kind of hanging out by itself. And so how do we kind of use some techniques to make that work well? Finally, as you're sort of progressing past that ideation and MVP stage, you're going to want to make your apps easy to maintain. And of course, what comes along with that is how do you test these apps, right? So if you're working for a company like Zappos and people are adding items to the cart, you want to make sure that works, right? You don't want them to get to a checkout page and all of a sudden there's no products there. Like that's no one's going to be happy about that. So yeah, let's kind of walk through these challenges. And I want to start first with the building blocks that Flutter provides, right? So I think it's important to sort of see what the framework gives you and think about when we can keep it simple and when we can use these building blocks, and then when we might need to naturally progress past these building blocks to more advanced solutions. So the first thing, of course, is the Stateful Widget. This is sort of the bread and butter of state management for Flutter, right? And Stateful Widgets themselves are pretty simple. They just sort of take in some properties in the constructor params. In this case, it includes a title, but it could include some other information. And then they sort of just create this state class that you write, and they kind of get out of the way. So let's look at the state class, because that's where actually the interesting stuff starts to happen, right? So we've got my homepage state. I literally stole this just from the Flutter create example, just to keep it simple, And so now we've got, for example, just our counter. So this is the first responsibility of the state class, is to define, hey, what kind of information does my application need to render? The second thing that the state class will often contain are methods to update the state. And this is where it gets a little interesting, because we're not just incrementing the counter, but then you're also using the setState method from the state class. And what that'll do is it'll run that function that you give it, and then after it runs that function, it'll actually tell Flutter, hey, go ahead and rebuild this widget tree, or mark this tree for needing a rebuild. Then finally, the third thing that your state class often does, or needs to do, is actually define the UI in the build method. So in this case, we'll just pass the counter that we've got to a text widget. We'll pass that increment counter to a button of some sort, so that when you press on it, it'll go ahead and increment the counter, tell Flutter to rebuild that widget, and then everything works, right? So I think maybe some of you are thinking like, okay, that's like a super simple example, but I actually think it has a lot of really interesting little concepts wrapped up inside of it. So, our widget tree at this point is really simple, right? We've got a stateful widget, and it's sort of handing some information off to a text widget, and a button. It's handing off the increment counter to a button widget. But more often than not, our widget trees are going to be more complex or interesting, right? Your designers are going to throw some cool stuff at you, and they're going to ask you to make some cool layouts. And so you're going to start nesting widgets a bit more. And you might need to send that data a little bit further down your widget tree. And the most common way and the simplest way to do that is to simply pass the state from your stateful widget down the widget tree, right? So say we need some information, or we want to pass our counter and our increment counter down to these widgets that I'm trying to highlight here. So what we can do is we can actually, maybe you've got a stateless widget, you can create another constructor parameter, and it will take the counter. It will pass that counter further down the tree to another stateless widget that takes in the counter. And then finally, that'll get rendered by a text widget or something in the end. On the other side of our widget tree, we want to pass down increment counter, and we can do this infinitely deep, right? We can actually continue to pass values down the widget tree. And this is a really nice and kind of tidy way to go ahead and actually pass state around. So then when you tap on the increment counter, or on the button that we've passed increment counter to, it'll go ahead and call that method, of course, on the stateful widget. The stateful widget will say, hey, I need to redraw at this point. And then it'll once again pass the counter back down and display the new value. Cool. So this is actually a really fundamental concept of state management, and it comes from React, and it's a concept called lifting state up. And so the idea behind this is that if you need to share data amongst different widgets, what you can do is you can create a stateful widget at the parent or the root of those different widgets that need the information. And then you can pass the information from the stateful widget down to the different parts that need it. The interesting thing is that this also applies to sharing data across screens, right? Because what you can do is you can actually pull the stateful widget all the way up above your application. So this is really cool, right? We just heard Phil talk about how everything is a widget in Flutter. And so what we can do is we can just pull that stateful widget above your widgets app or your material app. And that's the actual widget that's responsible for creating different screens in your application, right? That's where you like navigator.push some new route or navigator pop. And so we can actually use this technique to pass information down to different screens. So while it might seem simple at first, you actually, using this basic technique, can start to share data amongst your screens and have it re-render every time that data changes. So let's keep going. Let's progress, right? We want to start calling web APIs or maybe a database. So now what we'll do is we'll sort of start to enhance our state class. We'll throw a Boolean in there of whether it's loading or not. And that way our UI can show a loading status or maybe, or the actual counter if it's true or false. And then what we'll have is we'll actually have a method within our state class that goes ahead and talks to the API. So we'll just call this fetch increment for right now. It'll return a future with an integer involved. And then we'll create an HTTP client in there. We'll actually go ahead and await for the client to get the information from our web server. This is just some pseudocode, but I'm just trying to get the idea across. Finally, we'll go ahead and decode that JSON, and then we'll return the value of the counter from the JSON. Then we'll actually, the method we'll want to use in our UI is called increment async. And so what this will do is it'll immediately, as soon as it gets called, it'll go ahead and say, hey, set state, I want to show my loading spinner, so show my state is loading. Then we'll fetch the increment from the API using the method we just created. And then after that returns, we'll once again set the state with the counter set to the value that we got back from the API, and we'll set loading to false. And so what this looks like again with our widget tree is that we'll pass increment async down. When we tap on that, then we'll go ahead and re-render the widget tree. The first render will of course have the loading state involved, and we'll show the spinner. And then when the data comes back from the API, it'll go ahead and pass the counter down, 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 and we'll see that the new value is actually rendered at this point. Cool, so you know, looking good, right? Some of you might be breathing into a paper bag with this architecture. You might be like, what is this guy doing? Where is he going with this? He's throwing everything into one class. Don't worry, friends, we'll get there. So we're actually updating the state of our app. We're talking to web APIs. We're sharing information across screens. Not so bad, right? If you're just writing a prototype or you're just learning Flutter, like this is a totally great way to get started. You're going to start making progress really quickly. But you're going to start running into these issues, right? Where if you want to make your app easier to maintain, to bring team members on, to share code between different things, throwing everything in this class might get a little hairy. And we'll also look at how this can be a challenge for testing. So let's start to challenge our UI a little bit. Let's make a UI change, right? So we want to move the widget that displays the counter from this part of our tree to this part of our tree. Oh God, right? So what do we need to do, right? We need to change this widget. It no longer needs to accept a counter, neither does this one. The stateful widget is actually lifted up too high right now, so we can make that a stateful widget. Then we push the stateful widget down one level. Then we add a counter parameter here, and then we can pass it down. So maybe not the best, right? If you want to start really revving on UI changes, this can be a good way to get started, but if you want to start making UI changes quickly, you're going to find, hey, this is actually maybe not the cleanest or the easiest way to do this, because it requires a lot of plumbing changes. So let's take a look at one solution, right? And that's the inherited widget. This is another building block, actually, that's provided by Flutter. And so what it will do is, rather than having the stateful widget pass state directly down to its children, the stateful widget will actually pass data to an inherited widget. And then the responsibility of that widget is to pass that information down to all of its ancestors in the widget tree. So we'll pass the private counter and increment counter down from the stateful widget to the inherited widget, and then it will expose those publicly. So now if we want that data down our widget tree, we can just say, my inherited widget of context, give me the counter. On the other side, we can say, my inherited widget of context, give me the increment counter method. And this makes it really easy. So if we try that challenge again, right? Let's say we want to move the button this time from this part of the tree to this part of the tree, okay? So we're just moving it. Now, this time it's really easy. We don't have to do any of that crazy plumbing or changes because we're still just relying on the inherited widget to pass that information down the tree for us. All right, it's not bad, right? There's a lot less plumbing now that we have to deal with. It's easier to move widgets around and change up your UI quickly. But you'll start to see that there's actually some interesting duplication between what lives in the state class and then also in the inherited widget. And you'll also see that the entire widget tree is actually rebuilt when this happens. You might have seen that actually with all of the stateful widget examples. And then of course the big question is, how do we test all of this, right? So let's look at another challenge, which is testing. So if we want to test this thing, like this was my initial dream, right, is I was just going to write a plain old Dart test. I was going to instantiate a new version of the state class. I was going to run the increment counter method and then just be able to expect that the counter has gone from 0 to 1. Now, unfortunately, that's not quite the way it works, right? Because this is a state class and it's kind of tied to Flutter, you actually have to use the Flutter testing utilities to test this type of logic. So what do we actually have to do is we have to pump a widget. In this case, I'll pump the entire app. I'm just doing that for simplicity, but sometimes you might need to add some extra information in there, like a directionality widget to get your stuff to render. Then you have to find the button on screen that actually does the tapping and tap that. You wait for Flutter to draw the widget by saying, okay, let's pump the tester. And then finally, you would basically look at the widget tree that Flutter is rendering in the test environment and say, hey, is there a widget with, that's displaying this text? So if we kind of look at that challenge, we start to see that it's a little bit harder to work with, right? It's really I don't want to judge the widget inspector at all, or the widget tester at all, because it's amazing that this actually exists. If you come from Android, it can be really a pain to do this type of testing. And it becomes clear that this type of testing is great for UIs and UI logic, but you can start to see how our architecture that we've got right now, which might have been great if you were starting out or great if you've got an MVP, is starting to break down a little bit because we're mixing so many things into one class. So hopefully for those of you breathing into your paper bags earlier, you're starting to see that we'll overcome this challenge, right? And so the other thing is that if you're testing complex scenarios, this is almost impossible, right? Say you're doing some sort of interesting list transformations or something like that. To be able to test it with the widget tester would be really difficult. And it becomes even messier when async code is involved. And the reason is that the test widgets function does some interesting stuff to override the way async works in Dart, which makes it makes it work really well for widget tests, but not so. It makes it a lot more complex if you're dealing with databases or APIs. So what's the solution to this problem? And that is layering. And so we heard a bit about this yesterday, and so let's dive into this a little bit more as well. So you might have seen the layers in action. This is Flutter's sort of layered diagram. But we can actually use layers in our own apps as well, right? And so if we look at the responsibilities of our state widget, it's got sort of 3 responsibilities right now, right? It's sort of defining the state and learning how to fetch data for that. It's also got some logic about how the counter should get incremented. You might have, in a real world application, you might have some interesting rules around when that counter can actually get incremented or how it gets incremented. And then finally, we want to draw the UI, right? And so all of that right now is contained within one class. So let's look at how we can actually start to break this out. The first thing we'll look at is the data layer. So the data layer, the easiest thing we can actually do is just extract that function out into its own file or something like that. And then what we'll do is, rather than creating the HTTP client internally, we'll actually inject the HTTP client. So you might have also seen this exact technique used yesterday. And the reason it's so powerful is because if you're in a browser context, you can provide the browser client. If you're in Flutter itself, you can provide the I/O client. And if you want to actually test these functions, you can provide a mock client. And so this gives you full control over how and the environment that you're executing these things in. And it's really powerful for testing and for sharing code. Now, this function could actually be used cross-platform as well. That's just a natural sort of thing that happens when you extract it. The rest of the function is basically the same. We'll use the client that we're given instead of creating it internally. But the function remains essentially unchanged. So then we kind of come to this domain layer. And this is where you actually have a ton of good options, I actually think. So I've been working a lot with RxDart and stream-based architectures. There's also some other interesting projects called Scoped Model, which comes from the Fuchsia code base. I've just ripped that out shamelessly and published it as a pub package if you want to give it a shot. And then the final thing is, there's a lot of options here, but one of the popular ones that I've seen coming up is different types of redux architectures. So I'll focus on that because that's a library I'm helping to develop. And so it's just the Redux package on pub. And so let's take a look at how that would work. So Redux itself is going to be all pure Dart. And so in this case, what we'll do is we'll define the state of our application. And so this is a little bit different than the state class. This just means what sort of data does my application need? And this might be a list of to-dos or a list of products, things like that. But basically, it's just a plain old Dart object, and it should be an immutable Dart object. And so you can use just the immutable annotation, or you can use built value if you like that kind of thing, to create these sort of immutable state objects. In this case, we only need the counter, so we've got a super simple one. The second thing you'll need is, OK, so you're like, OK, your state's immutable. How do you change it? And so you change state in Redux by dispatching actions. And so for now, we'll keep it simple, and we'll only have the one action in our app. Eventually, you can define many more of these. And in Redux, these are just simple either enums or maybe classes. Classes are necessary if you want to deliver some payload information, such as like an ID, along with the action. So, but in our case, we actually don't need any payload information, so we can make it just a simple enum. Then what we'll have is, in order to update the state, we'll have a function that's called a reducer. Now, this is kind of a crazy name. It's just a function that takes in 2 parameters and returns something. So I don't know, reducer, don't let that name scare you. I think it scares a lot of people off. It's like a monad or something. Yeah, don't worry about it. It's not a functor or anything, or it probably is. I don't know. But yeah, so all this function does is take in the previous app state and the current action that's been dispatched, and it will return a new app state. And that's all there is to it, really. So in our case, once again, because this is a simple application, we'll just say, like, hey, if the action that was dispatched, it was an increment action, we'll want to return a new version of the app state and increment the counter while we do so. If we don't know how to handle the action, like some joker's just dispatching some crazy actions, we'll just return the previous state. No harm, no foul. And then we tie all this together with the store. So the store itself just takes in one required parameter, which is the reducer, and you can optionally provide an initial state. And so what we can do with this is then we can immediately create the store and start using it. And so we can just actually immediately print out the store's state. In this case, we just want to print out the counter. Since we're initializing it with a counter of 0, it'll print that. And then we want to change the state, so we'll start dispatching actions, right? So we can do a dispatch, we'll dispatch our increment action, and then at that point we can print out the state again, and it'll be 1. Notice that this is all synchronous. And that's sort of by choice, because that makes it a little bit easier to work with and reason about. So now let's take a look at that testing challenge again. Because we're just dealing with a simple function, we can actually write a really easy test for this reducer, right? So we'll we'll actually just test the reducer. We'll just call that function with a given app state that will, the previous app state. We can, the action we give to it will be an increment action. And then we can expect that the new state that's returned from that is equal to 1. And so you've actually gained a lot of testability here. Because all of this is just pure Dart, it's all extracted out of the state class, you can actually really easily test this. And you can also share this type of code cross-platform. That's not necessarily the point of this talk, but it's just like a cool benefit that you get for kind of extracting this layer out. So then let's talk about the UI layer, right? Because this is a Flutter talk, I'm going to discuss Flutter, but this stuff could also be hooked up to Angular as well. So in this case, what we'll do is we'll actually use a library called Flutter Redux, which sort of melds Redux with Flutter. And it provides something called a store provider. And that's a widget that you put at the very top of your hierarchy. And guess what? It's an inherited widget. So that's really cool, because that means that the store is being passed down to all of the descendants. So now if we need the data at these points again, we could just be naive and actually use the power of inherited widget. So we could say, hey, store provider, give me the state of the counter right now. And on the other side, we could have our button, and when it's tapped, we'll say, okay, store, I want you to dispatch that action. So this is going to be interesting, because then if we tap on this thing, you might have noticed, where's the stateful widget, right? So how do we actually tell Flutter to redraw? So it will actually dispatch this action, the store will be updated, but what about state changes for Flutter, right? So this is where we'll introduce another concept from Flutter Redux, which is called the store connector. And this widget is actually hopefully pretty simple, but what it has is 2 required parameters. The first parameter is what's called the converter. So this will actually be given the full store, and you can convert that into some type of view model. So in this case, our widget only cares about the counter, so we'll just extract the counter out of the state. The next required parameter is a builder method, or builder function, and you might have used these before. There's like widget builders, or if you've worked with the stream builder, it's got its own sort of async snapshot builder. And so this will actually have a builder method or function that takes 2 parameters, and the first is, of course, the build context, which you always need. And the second is actually the view model that you've gotten from the converter. So in this case, we're just extracting the counter, so I'll just name the view model counter, it's the integer. And then you can render whatever widgets you want from this. So if we try that tapping action one more time, we can go ahead and swap out the store provider and, of context and grabbing the counter directly for our store connector widget. Now when we tap on this, it'll update the store, and the store will actually emit changes, and that's what the store connector is listening to. It's listening to changes to the store, and then it'll say, okay, now that I'm connected, I know that I need to redraw. And so it'll go ahead and just redraw that one widget that you provide. All right, so if we try that UI challenge we had earlier, if we want to move the counter that we're displaying from here to here, we're all good. We're using a store connector, we're using our inherited widgets that we used earlier, and it's all good, right? We can just do that super easily. All right, so we did it. We can update the state of our app, we can rebuild when the widget changes, we're sharing data across screens and across widgets, we're hooking our widgets up to databases or web services. Now, unfortunately, because this is a bit of a shorter talk, I couldn't describe the methods that Redux has to do that, but there's a good solution for that with Redux. And the other cool thing is that we're starting to gain some really nice things, which is that we're going to make our app easier to maintain because we can test all of these things really easily. They're all isolated, so they, if you've heard of the single responsibility principle, we don't have everything sort of stored in one class anymore. We're sort of splitting that logic out into different logical units. The other cool thing is we get some bonuses here, right? So the Redux code itself can actually be shared across the platforms. And actually, even in our data layer, we can share that across platforms, which is really pretty cool. We're getting some other interesting benefits, which is that you might have seen we're only redrawing part of the widget tree now. Because the store connector is the only thing that cares about the state changes, and we haven't lifted our state up to the very top, the only widgets that will get rebuilt are the store connector widgets. Another really kind of cool bonus of this is that you can actually get some really interesting crash reporting. So if you're working with a big consumer app, it's really natural to have something like Crashalytics or Sentry so that when users encounter errors, it'll send a crash report up, and you can actually start to aggregate those crash reports and say, like, oh man, all of our users are crashing on this screen and this part of our app. But a lot of times you're like, how did that happen? Like, how do I reproduce it? You might be getting some user reports, or you might just have this like random line in a huge stack trace in Crashalytics, and you're like, oh god, how do I deal with this? And so this is really cool because what you can do is, if you use something like Redux or this type of pattern, what you can do is you could actually say, okay, let's send up the state of the application, and let's send up the last 10 actions that actually happened. And now what you can do is you as a developer, you can read that in addition to the stack trace, and you can actually reproduce the actions that the user took really easily. Another kind of interesting benefit that I didn't quite have time to talk about is Redux was basically built to work with hot reload. And so you actually have some Redux dev tools. And so as you're modifying your reducers, if you have your Flutter app running live next to it, you can actually change your reducers, and it'll replay all of the actions that have happened up until that point, and then it'll actually go ahead and just redisplay that. So it's really kind of an interesting way to work because maybe you've added 5 to-dos to your to-do lists, and then you decide, oh, actually, I want to add to-dos to the top rather than the bottom. It'll actually just go ahead and recompute all of those things and show you the result of that. The other, I think, thing that's really kind of interesting is that this is Redux is like, I'm not only trying to sell Redux. I love streams. I actually think there's some interesting stuff. But I think it's a proven concept, right? You have a lot of big companies like Airbnb and Netflix and these types of companies using this type of pattern for a couple of years. And they've sort of done the hard work of solving the challenges that come with these types of architectures. And so there's a lot of good resources out there for how you can structure your apps by feature, how you can share code across different apps, things like that. All right, so let's look at a recap real quick. So we started out with a really, it's not great code, but don't worry about it. It's working for you. If you have a prototype or if you're just getting started, feel free to throw everything in your state class. Like I said, don't worry if that just like freaks you out. It's not a big deal, right? Like we want to encourage newcomers to learn these things and to get better with them. And if they can see successes really quickly, that's totally cool. So the second thing is that once you start to run into some maintenance issues, consider layering as a solution to that problem. So yeah, this was a super simple example with just a counter. If you want to see a more advanced version of this, I've actually been trying to publish a few different examples of how to build a to-do app using lifting state up, using inherited widgets, using scoped model. I've also got a couple of Redux packages on there as well. So yeah, please check out fluttersamples.com. I've got links to all these different resources and all these different examples, in addition to maybe just demonstrating how you can write integration tests as well, and how you can share that data layer. All right, thank you so much.